can simplify fractions by removing the surds from the denominator. We call this rationalising the denominator. If the fraction is in the form k over root a, then we multiply the top and the bottom by root a. If the fraction is in the form k over a plus root b, then we multiply the top and bottom by a minus root b. If it's k divided by a minus root b, then we multiply by a plus root b. So we multiply the top and bottom of the surd by what's on the denominator, but with the opposite sign between the number and the surd. We can also complete questions such as this, where we have root a plus or minus root b. Again, we multiply the top and bottom of the fraction by root a, and then the opposite sign, plus or minus root b. So if we look at example 1, this is the simplest case, where we have a number divided by just a surd. So we multiply the top and the bottom by root 3. So we get 15 divided by root 3 times root 3 divided by root 3. So if we multiply the top, we simply get 15 root 3. And on the bottom we get root 3 multiplied by root 3, which gives us root 9. And we know that root 9 is just 3. If we multiply a surd by itself, then we always just get the number inside the surd. In this case, we've got 3. We can now simplify this further. 15 divided by 3 is just 5, so we end up with 5 root 3. The second question is harder. This time, because we've got 1 plus root 3 on the bottom, we multiply by the same terms but with the opposite sign between them. So 1 minus root 3 divided by 1 minus root 3. It's easier to now break this into the top and the bottom. So if we just look at the top, we've got 4 minus 2 root 3 multiplied by 1 minus root 3. So if we expand this, we get 4 minus 4 root 3 minus 2 root 3 plus 2 root 3 times 3, which is 2 times 3. We can simplify that to get 4 minus 6 root 3 plus 6, which gives us 10 minus 6 root 3. We can now do the same on the bottom. So we've got 1 plus root 3, 1 minus root 3. We can expand this like we have done above with the first bracket, or we can notice that it's the difference of 2 squares. So it's simply the first term squared, take away the second term squared, which is 1 minus 3, which gives us minus 2. We can now put this all back together. So if we go back to the original question, when we multiply the top and bottom by 1 minus root 3, we get 10 take away 6 root 3 on the numerator, on the top, and minus 2 on the denominator, on the bottom. We can simplify this further by dividing both terms on the top by minus 2. 10 divided by minus 2 gives us -5, and -6 root 3 divided by -2 gives us +3 root 3. If we look at part A, the perimeter of a shape is just the length of all the sides added together. So we've got root 27 plus root 27 plus 2 root 12 plus 2 root 12. We can't add these together unless the same number is in each of the square roots, so we need to see if we can simplify each of these terms. Firstly, we can collect like terms though and simplify it to just give us 2 root 27 plus 4 root 12. And now we can look at simplifying further. So root 27 we can write as the square root of 9 times 3, and 12 we can write as the square root of 4 times 3, which simplifies to give us 2 times the square root of 9 is 3, root 3, plus 4 times the square root of 4, which is 2 times the square root of 3, so root 3, which gives us 6 root 3 plus 8 root 3, which gives us 14 root 3. So if we now look at part B, we're asked to find the area of the parallelogram, which is equal to the base times the perpendicular height. The base we know is root 27, and the perpendicular height we're told in the question is 10 divided by root 3. Which gives us 10 root 27 divided by root 3, which we can write as 10 root 27 over 3. We can simplify this simply to 10 root 9, and root 9 is equal to 3, so 10 times 3, which gives us an area of 30 meters squared. Now have a go at the textbook exercise 1F, page 15, and do questions 1 to A to D and 2 E to I. The green are the easiest questions, the red are the hardest, but you need to do all of them, and if you're struggling, come and see one of your teachers.